Hello and welcome to this Unified Communication Self-Training Class GCS level. My name is Ilyas Namaran and I'm a Regional Product Engineer here at Grandstream EMEA, and I'm in charge of the Unified Communication Solution. And in this class, we're going to talk about how to set up our UCM 6300 series and how to deploy them correctly. In this class, we're going to talk about physical installation, understanding LCD menu, and then we're going to talk about web and user management. Then we're going to talk about the setup wizard that will help you set up your UCM 6300 series. And lastly, we're going to talk about zero config, which is Grandstream provisioning system. Let's start with the physical installation, where we are going to discover the interfaces on the UCM as well as the instructions on how to set up a UCM model from an out-of-the-box state to a fully functional state. The first model that we're going to talk about is the UCM 6510. As you can see from the slide, we have an illustration of the front and the back panels of the UCM 6510. On the front panel of the UCM 6510, we have a USB port, SD card slot, 2 FXS ports, 2 FXO ports, LED indicators, an LCD screen, and navigation keys. On the back panel, we have 2 DC 12 volts power jack inputs. We have 1 reset pinhole button. We have 1 LAN port, we have 1 WAN port, and we have a heartbeat port, and we have a grounding interface. In order to connect the UCM 6510, connect the RJ45 Ethernet cable into the UCM 6510 WAN port and connect its other end into the uplink port of an Ethernet switch or hub. Connect the 12 volts DC power adapter into the 12 volts DC power adapter jack input on the back of the UCM 6510, and please note that you can connect the second power adapter into the 12 volts DC power jack for failover purposes in case the first one stops working. Wait for the UCM 6510 to boot up. Once the UCM 6510 is successfully connected to the network via WAN port, the network LED indicator will be lit green and the IP address will be shown on the LCD display. These following connections are optional depending on your deployment of the UCM 6510. You can use the PSTN connection, the analog line connection, and the T1, A1, J1 line connections, which are telephony standards that are supported by our UCM 6510. And then we have the UCM 6300 series. We're going to talk first about the UCM 6301, UCM 6302, the UCM 6300A, the UCM 6302A, and the UCM 6304A, since they all feature the same design. And the first thing that we are going to look at is the LCD screen in order to show hardware, software, and network information. And since these two models do not include LED indicators for all available interfaces, LCD screen can also be used in order to check the status of these ports. Navigation keys, just like all the UCM models, they make it easy for users to navigate through the menu with the home button, the OK button, and the back button, settings button to access the menu. The navigation keys allow going down and up on the menu settings. And we have information button that will take you directly to the UCM information page on the LCD screen. And the interface status button that will take you to the page showing the status of all the ports available on all the models of the UCM 6300 series. On the back, we have a power jack of 12 DC to power up the unit, a reset button to restore the device to its factory settings, LAN, WAN, and heartbeat ports, FXS and FXO ports. The number of available FXS and FXO ports varies depending on the model, so to know which model supports which number of FXS or FXO ports, please refer to our website. And please note that all our FXO ports support lifeline capability in case of a power outage. And on the front panel, we can find a USB interface and an SD card slot used to store recordings or backups. Only one SD card slot is available in both models, while for the USB ports, only one USB 3.0 is available on the UCM 6301 and 2 USB 2s and 1 USB 3 in the UCM 6302. Let's talk about the initial setup of the UCM 6301 and the UCM 6302. The first thing that we need to connect is the network port. Users should connect one end of an RJ45 Ethernet cable into the WAN port of the UCM 6301 or UCM 6302 and connect the other end of the Ethernet cable into the uplink port of an Ethernet switch or hub. Next, you need to connect the 12 volts DC power adapter into the 12 volts DC power jack on the back of the UCM 6301. We should also know that all the models of the UCM series can be powered using PoE+. The UCM6301 will boot up and the front LCD display will show the UCM's hardware information when the boot process is done. Once the UCM is successfully connected to the network, the LCD will display the IP address and the users can check the port's status from the LCD screen by clicking on the interface status button. And we have the optional connection depending on how the UCM6301 is being used. You can connect PSTN lines from wall jack to the FXL ports, as well as connecting analog lines, either phone or fax, to the FXS ports. Now let's talk about other UCM6300 models which feature a different design. And those models are the UCM6304, UCM6308, and UCM6308 audio. And for these UCMs, on the front panel, we have the LCD screen, the navigation keys, LED indicators for all the interfaces status, 2 USB 3.0 ports, and 1 SD card slot. And on the back panel, we have a power jack of 12 volts DC to power up the unit, a pinhole reset button, LAN and WAN and heartbeat ports with PoE+. For FXS ports, we have 4 FXS ports available on the UCM6304, while there are 8 FXS ports on the UCM6308 and 6308 audio, supporting lifeline capabilities in case of a power outage. The number of FXL ports is also different for these models. The UCM6304 model supports 4 FXL ports, while the UCM6308 and the UCM6308 audio supports 8 FXL ports, and they're all with lifeline capability in case of a power outage. Same as the previous models that we have talked about of the UCM6300 series, the initial setup of the UCM6304 and UCM6308 should start with connecting the network ports, plug in an RJ45 Ethernet cable into the one port and connecting the other end in the uplink port of an Ethernet switch or hub. Next, we need to power the unit by connecting the 12 volt DC power adapter into the 12 volt DC power jack. And for power redundancy, you can connect a second 12 volt DC power adapter into the other power jack, but it's optional. The UCM6304 will boot up and the front LCD display will show the UCM's hardware information when the boot process is completed. Once the UCM is successfully connected to the network, the LED indicator for WAN in the front will be solid green and the LCD will display the IP address. And we have optional connections depending on how the UCM6304 is being used. You can connect PSTN line from the wall jack to the FXL ports, as well as connecting analog lines, either phone or fax, to the FXS ports. There are 3 network methods that can be configured in the UCM, which change the behavior of LAN and WAN ports. The first one is route mode, where the WAN port will be used for uplink connection and the LAN port will be used for the local area network. In other terms, the UCM WAN port will have a public IP address configured, while the LAN port will provide the ACP addresses that connect multiple phones and devices in the LAN network. Second method is the switch mode, where the UCM will be bridging the LAN and WAN ports. And basically, the UCM will not be managing the ACP addresses for the phones and will itself be assigned an IP address by the router. And the third is dual mode, where both WAN and LAN ports will be used for uplink connections. WAN port will be mapped as LAN 1 interface, LAN port will be mapped to LAN 2 interface. Basically, the first one is for SIP dedicated trunk and the other one is for local network and internet access. We're going to learn in this section about the LCD menu of the UCM models and which settings can be configured from it. The first level is idle screen. Once the device has booted up completely, the LCD will show the UCM model, hardware version, and IP address. Upon menu key press timeout, which is 15 seconds, the screen will default back to this information. And pressing the down button will show the system time. The second level is menu pressing, and pressing the OK button will show the main menu. We're going to see together what can be found in the menu from the LCD in the next slide. The menu navigation, pressing down button will scroll through the menu options. Press OK button to select an option. To exit a menu, pressing on the back button will return you to the previous menu. For the device info, network info, and web info screens that have no back option, pressing the OK button will return to the previous menu. LCD backlight will turn on upon button press and will go off when idle for 30 seconds. View events, critical events, and other system events. Device info. In this LCD menu section, users can see the most important information about the UCM device, such as the hardware version, software version, part number, MAC address, and uptime. In network info, this section is dedicated to show the mode that the UCM is configured to use. It can be the HCP static IP or point-to-point over Ethernet. IP address of the UCM is shown in this section, as well as the subnet mask. Network menu, users can modify the network settings for LAN, WAN, the HCP static IP, and point-to-point over Ethernet in this section. In factory menu, you can reboot the UCM. You can restore it to its factory settings by selecting reset. LCD test patterns, to test the LCD patterns with the buttons available on the UCM. The UCM has a built-in fan that users can set it to on if they want the fan to be constantly spinning, or it can be set to auto if the user wishes to trigger it only when the UCM's temperature increases. LED test pattern in order to test if all the LED indicators are working as intended. RTC test pattern or real-time clock test patterns in order to check the system time from the LCD screen. Hardware testing is a test dedicated for hardware connections verification within the device. For web info, users can choose the web access protocol, either HTTP or HTTPS, but by default HTTPS is configured, the same for the web access port number, and the default port is 8089. SSH switch, users can enable or disable SSH access from the LCD menu. Port status, in order to check the port status for all the models of the UCM 6300 series. And now let's move on to the web and user management. The UCM's web server responds to HTTP and HTTPS GET and POST requests. Embedded HTML pages allow users to configure the device through a web browser, and by default the UCM uses HTTPS as web access protocol, and the port number is 8089, and the default LAN IP is 192.168.2.1:8089 for port when using the route mode. By default, the UCM 6000 has redirect from port 80 enabled. Therefore, if the user types the UCM IP address in the web browser, the web page will automatically redirect to the page using HTTPS and port 8089. And now let's talk about the levels of management. We have the super admin. This is the highest privilege who can access all the pages on the UCM web interface, change configuration for all the options, and execute all the operations. View the operation logs generated by all the users. Super admin could also change its own login password to access the web interface and could view operations done by all the users. And most importantly, you should know that you can only have one account with super admin privilege. Administrator, users with admin privilege can only be created by the super admin user, and they're not allowed to access certain functionalities like upgrade, cleaner, reset and reboot, operation logs, and user management. But for the user manager, it can be accessed by the administrator, but with limited access. They can only change the password and information of their accounts used and of the consumers as well. You should also know that admin privilege users cannot create other admins. Consumer, regarding this type of accounts, the system will automatically create user accounts along with creating new extensions for extension users to log into the web GUI using their extension number and password. You can log into the consumer account with the extension number and password, and you can access user information, extension configuration, CDR of that specific extension, personal data, and value-added features. Super admin could create users with different privileges. There are 38 modules available for privilege customization, and I listed them in the slide. For example, the super admin can create an account that can access only CDR records, meetings, extensions, etc. After logging into the UCM web portal for the first time, the setup wizard will guide the user through basic configurations. Let's discover together these configurations. We always recommend to change the password for the super admin once you access the UCM for the first time. This is why this is the first part of the setup wizard. The network parameters for the device are also recommended to be configured in the beginning. The third section is the time zone configuration in order to select the proper time zone option so the UCM can display correct time. Extensions. Users can create new extensions using the setup wizard. Trunks and routes can also be configured directly in the beginning using the wizard. At the end of the wizard, a summary of the pending configuration changes can be reviewed before applying them. And of course, the setup wizard can be closed and reopened at any time. And next, we're going to talk about a very important aspect of installation of deployment of the UCM, and it is our very own provisioning system that we call zeroconfig. And please note that Grandstream SIP devices can still be configured via web interface as well. as via configuration files through TFTP, HTTP, and HTTPS download. All Grandstream SIP devices support a proprietary binary format configuration file and XML format configuration file. All the UCM models provide a plug-and-play mechanism to auto-provision the Grandstream SIP devices in a zero configuration manner by generating XML config file and having the phone downloading the configuration file. To provision a phone, 3 steps are involved: discovery, assignment, and provisioning. Basically, the UCM will create an XML configuration file of the detected and assigned Grandstream device and accomplishes the configurations on the device after the provisioning. We're going to go into details in the next slides about the steps involved in zero config provisioning. This is basically the mechanism of zero config. The UCM LAN interface has DHCP enabled and has assigned the devices with an IP address. When the UCM offers an IP address to the phone, it also offers the HCP option 66, which provides the phone with a configuration server path that points to the UCM. All of Grandstream VoIP devices have option 66 turned on by default, and this is how the devices are discovered by the UCM. And upon being discovered, the devices will provide details about their MAC address, IP address, firmware version, vendor ID, model number, and connection status. After the discovery of a device, if the configuration file is available, it will be downloaded by the device after receiving the downloading URL from the UCM. If the config file isn't available, it should be created and the URL should be sent to the device in order to download the configuration file, and the device will get provisioned. In addition to the HCP option 66 for provisioning the devices, we also have SIP subscribe and MDNS. Like it has been previously explained, Grandstream endpoints are automatically discovered after boot up. Users could also manually discover the devices by specifying the IP address or scanning the entire LAN network. There are 3 methods of zero config discovery, either through ping or ARP, which is Address Resolution Protocol, or by SIP message notify. The info provided in the discovered devices list depends on the method used. The screenshot is showing the information showed when discovering devices using SIP method. Auto Discover can also search for devices located on other subnets in condition for the other subnets to be added under the subnet whitelist from the zero config settings. The method allows to discover other subnets when the discovery method chosen is SIP message. And beside the built-in discovery method on the UCM, users also could prepare a list of devices on a CSV file. You basically need to make sure that the CSV file respects the format recommended and that the entered device's information is correct, like valid IP addresses, valid MAC addresses, correct device model, and an existing extension. Otherwise, the UCM will reject the file and the operation will fail. Customers have options to well-manage zero configuration, especially when there are many devices are being deployed or used. For instance, users can either automatically send to the SIP device the URL to download the config file, and therefore the SIP device will be automatically provisioned once the device is discovered, or you can manually push the configuration to the device by clicking on Notify on the UCM. And this can be done using option automatic configuration assignments. Besides that, you have also the ability to assign automatically to Grandstream endpoints extensions from a specific extension range and send it with the whole configuration that has been set. And this can be done by enabling the option automatically assign extension. The range of the extensions that can be assigned can be found in the zero config extension segment, where you can customize this range. Make it wider or narrower according to the number of the deployed devices and the size of your business. And to backtrack a little bit to what we have said before about discovering SIP devices in other subnets, the user can add those subnet addresses to the whitelist to be able to provision those devices using the option Flexible Network Segment Whitelist. When using the zero config template, you need to take in consideration the zero config architecture. When using the zero config template, you need to take into consideration the zero config architecture that we're going to look at in this slide. The lowest priority goes for global policy template, which can be used to configure some basic option that could apply to all Grandstream endpoints during the provisioning process regardless of the model. So any change you configure on a global policy will apply to all the devices managed by the UCM zero configuration feature. On top of global policy, there is global template. The main difference between global policy and global template is that global policy applies automatically to all the Grandstream devices, while for global template needs to be selected and applied to devices. In other words, you need to go to the device configuration, then select the right global template in order to apply it for that specific device model. Then we have the layer that comes third in priority, and it's model templates. And model templates can be used to apply specific configuration to all devices of the same model number. And last, we have the highest priority of device configuration, where you can configure device-specific options for individual devices, which means that the configuration done in this layer will be dedicated to a specific device with a specific MAC address and IP address. What is very important to remember here is that the configuration options in model layer and device layer have all the option in global layers already, and the option in global layer, like global policy and global templates, is a subset of the options in model layer and device layer. If an option is set in all three layers with different values, the highest layer value will override the value in the lower layer. For example, if the user selects English for language settings in global policy and Spanish for language settings in default model templates, the language setting on the device that will be provisioned will use Spanish, as model layer has higher priority than global layer. But in order to do the provisioning for your devices, there is no need to go through all the layers. But in the case where you do, we recommend that you use layer 1. Just to remember that configuration in higher layer will always override the configuration for the same options or fields on the lower layers when presented at the same time. Let's talk about each one of the layers separately, starting with global configuration layer. Global configuration layer will apply to all the connected Grandstream devices in the same LAN with the UCM, no matter what Grandstream device model it is, and it is divided into two levels. Global policy, which is a general configuration layer where users can set the configuration settings shared by all Grandstream products. Users can navigate to the following categories to set the needed configuration, like localization, phone settings, contact list, maintenance, network settings, customization, and communication settings. And the second level is global template, where users can create multiple global templates with different sets of configurations and save the template. Later on, when users want to configure the device, they can select to use one of the global templates for the device. The selected global template has higher priority to the global policy. If the same setting has different values configured in the global policy and the selected global template, the value for this option in the selected global template will override the value in global policy, as we have said before. Model layer configuration allows users to apply model-specific configurations to different devices. If multiple model templates are created and enabled, when the user configures the device, the user can select to use one of the model templates for the device. For each created model template, users can assign it as default model template. If assigned as default model template, the values in this model template will be applied to all the devices of this model. There is always only one default model template that can be assigned at one time on the UCM, and the default model template will both take effect when generating the config file for the device. However, the model template has a higher priority to default model template when it comes to the same settings. If the same option has different value configured in the default model template and the selected model template, the value for this option in the selected model template will override the value in the default model template. But you also need to know that our free softphone application Wave can also be automatically provisioned with the needed configuration. And users could do that by configuring the email on the UCM in order to be able to send the QR code that will be scanned in order to register the extension. For device configuration, which is the highest layer, you could create a new device and make special configuration for that specific device that you have created. You can also perform other operations from device configuration zero config layer, such as delete some already created devices or send a notify to these existing devices. Besides configuring the device after the device is discovered, users could also directly create a new device and configure basic settings before the device is discovered by the UCM. Once the device is plugged in, it can then be discovered and provisioned. This gives the system administrator adequate time to set up each device beforehand. After going through the 3 layers configuration for the device, users could send notify to the SIP device and trigger it to start auto provision. But you should remember that it depends on the provisioning way and the device and the type of the configuration you wish to have on the device, that users can choose either to use one layer or more. The UCM offers some options after the device is provisioned. You can reboot the device, access its web interface directly, or you can use the sync button to resend the notify and update the configuration.